Hello, everyone. Welcome all of you to the fourth Ballerina community call. So I hope everyone is doing well. And I'm Irushi Diganage, a developer from the Ballerina team. And in today's session, we will be looking at what's new in our upcoming Ballerina future releases. And then we will move on into a session about Java interoperability in Ballerina. So this is an open forum where you can ask questions, and you can ask questions in the chat while the presentation is going on, or you can wait till the end and unmute and have a discussion with the Ballerina team and the community. So we will be recording this session, and we will be publishing it in our YouTube channel called Ballerinalang. And so I think that we can move on into a small description about the Ballerina community call. So this is a recurring meeting that we have every month, and so basically the community call structure will be as follows, as you can see in the slide. So we will start with a feature explanation and a demonstration, and then at the end of the session, sorry. I'm sorry, the screen has now been shared. I hope you can see the screen now. Okay, cool. Sorry about that. And so let's look at about how the community call works. Like I said, this is a recurring meeting that happens every month. And during the community call, we will pick a certain topic or a feature in Ballerina and then explain it along with a demonstration. And then we will move on into an open discussion where you can talk with the Ballerina team and the community. So there are some useful links here, the agenda, where you can look at the topics that we're discussing on a particular community call. And then you have a notify me form where you can subscribe to our Ballerina community calls. And then you have a topic suggestion form where you can suggest topics for upcoming community calls. Yeah, so the agenda for the day is we will be giving an update on the Ballerina Swan releases, and then we will move on into Java interoperability in Ballerina. So under Java interoperability, we will be discussing about 3 sections: calling Java code from Ballerina, generating bindings using the Bindgen tool, and packaging Java libraries with Ballerina programs. And then at the end, we will move on into an open discussion. So I would like to introduce Hasita, who will be presenting the section on the update on the Ballerina Swan Lake releases. So over to you, Hasita.
Okay, thank you, Rishi. Hello, everyone. My name is Hasita Ravinder, and I'm the lead developer and the architect from the Ballerina compiler team. Murkesh, can you move to next slide? Okay. A year ago, we released JBallerina 1.0, and since then we have released 2 minor versions and have done several patch releases. And the latest stable version is 1.2.11, which is released early this month. Since early this year, we have been working towards incorporating new language features into the language and improving the stability and usability of the existing language features. Some of these improvements have been added already to Ballerina 1.x releases, but along the way, we realize some of these new features require some significant rethinking and some left-breaking changes to the language core design. So this leads to born Ballerina Swan Lake, and it will be the next major version of the Ballerina platform. And we did our first preview release of the Ballerina Swan Lake in June 2020. And so far we have done 7 preview releases, and the last week we did our latest, which is Ballerina Swan Lake Preview 7. Hiroshi, move to next slide, please. Okay, thank you. Now let's talk a bit about future release timelines. So the next preview release is 8, and we are planning to release it in mid-December. And the main key feature of this release is the introduction of the new service design. And so for that, we have re-engineered existing service type such as HTTP, WebSocket, gRPC, and many more protocol and protocols on top of this new service design. And along with that, we are introducing new GraphQL listener support as well. So after Swan Lake Preview 8, we are planning to do another release, which is the alpha release, by completing all the Ballerina platform major features. And we expect to release in mid January 2021. And you can use this release to try out new features. And still, we will be working on fixing spec deviation, improving the APIs of the standard libraries, compile APIs, and improving the usability of tools towards the GA release. But we don't expect significant breaking changes after this release. So let's, Hiroshi, can you move to the next slide, please? Okay, now let's quickly talk about the new features available in the Swan Lake Alpha compared to the last stable release. So let's talk about the language features. As I mentioned earlier, new service support has will be added to the Ballerina Swan Lake. And with this, now you can write both resource-oriented services and the RPC style related service types. And we have introduced the immutability support. And with this, you can enforce concurrency safety at compile time. And then there are several improvements to type systems, such as we have introduced new types called never read only, and we have revamped the old table type and introduced a new table type, and we have introduced new stream type. And additionally, there are some usability improvements to object and error type as well. So after the another key feature is the improvement to error handling, and we have introduced new to construct and do and the on fail clauses to improve the error handling. And then we have new transaction support. Now you can statically type check transactional scopes in your source code, and then we have improved the query support, and then we have introduced new thing called, if you're familiar with the string templates and XML templates, so there's a new support for raw templates. So this is heavily used in this when creating SQL parameters. Uh, then we have introduced configurability support for the language, and there are more features we have introduced in this only. Hiroshi, can you move to the next slide, please? When we talk about the standard library, so as I mentioned earlier, so we have re-engineered HTTP, WebSocket, gRPC, and many more protocol connectors. And we are introducing new GraphQL listener support. And then we have revamped IO and log API, SQL modules, and email. Likewise, we have there are a lot of changes coming in and improvements coming in the standard library. Can you move to the next slide, please? Okay, thank you. So in the Ballerina platform, we have introduced a new concept called Ballerina packages in the Ballerina Swan Lake Preview 7. And then we have new code to cloud design. So this is basically the revamp of all Kubernetes and Docker annotation based extension. And we have introduced new Ballerina parser. And then we have introduced new compile APIs to interact with the compiler, and we are planning to introduce a Ballerina shell, which is experimental features. Basically, this is the REPL support for Ballerina and more. And there are a lot of more features available in the Ballerina platform. So most of these features will be available with the Swan Lake Preview 8, and we hope that you in the community are excited to try out these new features. And probably we will discuss more on these features during our next community call. That's the update from me, and back to the Rishi to discuss today's topic.
Thanks.
Thank you.
So let's look at, let's start with the Java interoperability session. So I'm going to start with a basic introduction into calling Java code from Ballerina. So basically, this will include a basic introduction into Java interoperability. So this is the structure, or we can say the flow of calling a Java API. As you can see, the last layer, or the Java API layer will be at the bottom, and then we will have a foreign function invocation layer on top of it. And then you can generate Ballerina bindings using the Bindgen tool, or you can manually generate, or you can manually write bindings. And then on top of that, you can write the Ballerina program. So basically, this is the flow of calling a Java APIs from a Ballerina program. And then I'm going to give you a quick update on foreign function invocation in JBallerina. So basically, the JBallerina compiler allows calling of Java APIs using external functions. So basically, external means the function, an external function, what it does is the implementation of the function resides outside of the Ballerina source. So basically, Ballerina, or the Java module available in Ballerina, provides 4 annotations for this purpose, and which we will be looking at in a later slide. And also, Ballerina has introduced a type called the handler, which basically refers to an externally managed storage. So this is important in the context of Java interoperability, because this handler type is what stores a Java reference type value. So yeah. Okay, I will give you a quick update on how the Java types will be mapped onto Ballerina types in Java interoperability, basically. So, so any reference type, including the null type, will be mapped on to a handler, and all the primitive types will be mapped on to corresponding Ballerina types based on the binding conversions. And similarly, the Ballerina types will be mapped on to Java types. So as you can see, the handler value will be mapped on to any reference type, and the primitives will be mapped on to primitives based on the binding conversion here as well. So if I'm to explain the foreign function invocations in Ballerina, so basically, if you want to invoke a static method, this is how you do it. So basically, this is an external function. So as you can see, the external keyword is used here, and the Java method annotation is used to specify the class that you're trying to invoke, and the name of the method along with the parameters that you're passing into this method. So something to note here is that if the function name and the name of the Java method that you're trying to call is the same, then you can avoid this field, avoid this name field. And then as you can see, this handler value here represents a reference of Java util.uid class. So, and this method returns back a handler reference, so handler type value. And then if you're trying to invoke an instance method, the difference is you will have to pass the the reference of the instance that you're using to call this method as the first argument of this method, of this external function. So that is pretty much the difference between static method invocation and instance method invocation. And then if you look at the constructor invocations, it is also pretty similar, but you will be using the constructor annotation instead, and you can give the class name. You don't have to give a name, and you can give param types, as in the parameter that you're trying to pass into this constructor. So also this param types field is also optional. If you don't have parameters, you don't have to pass it. And yeah, so let's move on to fields. So basically, this is also pretty similar, but instead of the method and constructor annotations, you will be using the field get and field set annotations, and you can provide the class and the name of the field. And here also, since this is an instance field getter, you will be passing the instant reference to the Java instant. And here also, we will be passing this and then the argument, the field value that you're trying to set. So in static field getters, you don't pass the initial handle value that represents the instance. Okay, I think we can move on. Okay, so now we can move on to the Bindgen tool. So as you might have noticed, if you have used Java interoperability before, you might have noticed that writing external functions and calling Java code is kind of a tedious task. You will have to create external functions for each and every method, and you will have to manipulate handle values. So this is not an easy task. So we have introduced a CLI tool called the Bindgen for this purpose. Okay, so let's look at the Bindgen CLI command. So it's basically a CLI tool for generating Ballerina bridge code for Java APIs. And so this is the command. So basically you can provide a class path containing the Java libraries, or you can provide multiple class paths, or you can provide a Maven dependency. So you can provide the group ID, artifact ID, and the version. And then you can provide all these are options. Options. And then you can provide an output path into which you want to create. You want to generate the Ballerina bindings into, and then you can have a flag for a public flag to make the module. Access qualifier to expose the Ballerina bindings. So by default, it would be module private. And then you can pass the fully qualified comma-separated class names, a set of class names that you want to generate Ballerina bindings for. Okay. You will understand this later along with the demonstration. I will go through and quick overview so that you will know what you're looking at when the demo is done. Okay, so Java to Ballerina mapping. So basically, when you're generating bridge code using this Bindgen tool, the tool will map a Java class into a Ballerina object. So basically, this demonstration and specifically this slide makes use of the 1-to-X branch. But there will be a few changes in the SLP branch, or the Swan branch, but you don't have to worry about it a lot because the Bindgen tool will generate the mappings or the bindings based on the language version. So you don't have to worry about it a lot. I just want to give you an idea about how these mappings are done. So basically, a Java class will be mapped on to a Ballerina object. An instance method will be mapped on to an object method inside the corresponding Ballerina binding object. And a Java instance field will be mapped on to an object method, so to two object methods inside the Ballerina binding object. So, and also the constructor, static methods, and static fields will be mapped onto Ballerina functions outside of the Ballerina binding object. So again, I will go through a generated binding to show you exactly how these mappings are done. Okay, so also when you're using these bindings, you note that java.lang.string object will be mapped on to a Ballerina string type, and the java.lang.throwable object or errors and exceptions in Java will be mapped on to Ballerina error type. So basically user-defined errors. And also the code generated from this Bindgen tool will be supporting Java subtyping, and also there is an option for performing Java casting as well. Okay, so before we move on to the next session, I think we can look at a practical scenario. So yeah, I will be using the Snake Camel library to carry out a small Java program in a small execution where I'm reading a YAML file and then traversing through some of its elements. So I will be using the Snake Camel library for this, and so yeah, let's see how we can get this done. Okay, so I will be creating a new project. Okay, and then gonna move inside this project. Then I'm gonna add a module. I'll load demo. Okay. So you can see the project is created, and so I'm going to show you a sample Java code. So basically, if you can look at the Java code and then write the Ballerina bindings, it'll be easier. Or if you, it'll be easier for the demonstration actually. So this is a very simple Java code that I'm using to load a YAML file and then get some of it and print some of the elements in it. So as you can see, this might not be the best way to write this code, but I just want to illustrate how this could be done. So this code basically imports these classes. So it means we will need to create Ballerina bindings for these classes. And apart from these classes, you will see that the string class and the object class are also being used here. Yeah, so even though we don't explicitly add the imports for java.lang package, we will have to generate bindings for these classes as well. Okay, so I think we can start generating, we can start executing the command. Okay, so if I type Ballerina Bindgen, we can see the help text. So this summarizes everything that the Bindgen tool can do. And okay, so let's generate the bindings. Ballerina Bindgen. And then I'm going to use the Maven command. You can specify a class path also instead. So I'm going to use this Snake Camel dependency, Maven dependency. As you saw before, you need to give the group ID, artifact ID, and the version. So I'm just going to copy this and paste it here. I'm going to remove this jar keyword. So as you can see, the group ID is there, the artifact ID is there, and the version is here. So I'm going to provide an output directory. I'm going to create this inside the load demo module. And now I can provide the classes that I fully qualified names of the classes that I want to generate. Okay, so I can copy this one by one. Okay, and I'm going to generate the string class and the object class as well. Okay, I think the command is good to go. Can execute it. Okay. As you can see, the command will resolve the Maven dependencies that the Maven dependency that you have specified, along with the transitive dependencies as well. Here it's just the snake camel job. Okay, so as you can see, the bindings are generated. So basically, the bindings will be generated into a folder called Ballerina bindings. So again, this is in the 1.2 branch. It will be slightly different in the Swan Lake branch, but it's not a major difference. I just want to show you how the bindings are created. Also, this will not be very relevant to you because you'll be an end user of these bindings. So the bindings that you specified, explicitly specified, will be generated inside this bindings directory. So you can see. Okay, and then in the dependencies directory, the dependent classes will be generated. That is, for instance, let's say all the public APIs inside a particular class that you have explicitly specified when generating bindings contain another class as a parameter or a return type. So those will also be generated, but it will be an incomplete or partial binding object, as in the implementation will not be there, just a representation of the binding object will be there. And then a utils folder will be created, and there's a subdirectory with the error types, the user defined error types, and constants.lat file, which is used for internal purposes. Okay, so let's look at the binding that is generated. So basically, this is what the binding object will look like. There's an annotation to specify the class name, fully qualified class name, as in these will be automatically generated. So you don't have to worry about it a lot. I just want to give you a brief understanding about the bindings generated. And also all the Ballerina binding objects will implement an abstract object called JObject from the Java module. And these are some util functions. And so this is an instance method that mimics the can execute method in the file object in Ballerina, file class in Ballerina. So as you can see, this is the function that mimics the can execute method. Okay, and let's look at, so these will be residing inside the Ballerina binding object. And if you look at a constructor, so this is a constructor. So basically the naming convention in constructors will be a little different. It will start with a new keyword followed by the simple class name of the Java class. And then it will append a numerical character, because the reason is Ballerina does not allow method overloading. So basically, we have to create new function names for each and every method. So we are appending a numerical value at the end of the method name here. Yeah, so these are constructors. And so this is a static method. This is also residing outside of the Ballerina object. And it will start with the simple class name of the Ballerina, of the Java class, followed by an underscore, followed by the method name. Again, here as well, in all the scenarios in the in methods and constructors, a numerical character will be appended at the end of the name if there are overloaded scenarios. Okay, so as you can see, a numerical value is appended at the end. So this is a field getter. So as you can see, a static field getter. So the short name underscore get keyword is there since this is a getter, and the name of the field. Yeah, so these are the external functions. These are also residing outside of the Ballerina object, Ballerina binding object. So this is for calling the constructor. This is for calling a method, an instance method, and yeah, as you can see, that's how these bindings are generated. Okay, so if we look at dependent object, you will see that an object is created and all the util functions are in it, but it doesn't have any implementation of the actual methods and constructors and fields. So now that we have an idea about the generated bindings, I think we can go into the demo, the example that I'm going to show you. So let's create this and create a new function. And then if we look at the Java code, so basically we are creating a new YAML object. We can copy this and we can create the same thing here. Or we create it inside the function. And we call this. And so as you can see, we will have to create a new YAML object. So new YAML will be the constructor for 0 parameters. And then we will create a file. So we need to create a file by passing a string. Okay, and this is actually a very simple scenario to explain how the bindings work. Okay. And we're going to create an input stream, a file input stream. We don't need to initialize with null. We can directly. This is the way how we handle errors in Ballerina is quite different to Java, so we can directly create the file input stream. Stream takes some file value. So as you can see, there's another creator. So this says what is expected is and file input stream or file not found exception. So I'm going to file not found exception. Okay. And so I'm going to check if the file is actually available or not. So if it's a file not found exception, we can write an error. printf. So the YAML file cannot be loaded. And we can give it's true. So in order to use this io.printf, we need to import the Ballerina IO module. Okay, and we can go to the happy bar. And then if it is there, I'm going to load this YAML file. Okay. So basically, if you look at the load method of this YAML object, you will see that it returns an object. So here, what it actually returns is a map. But the thing is, we don't support generics as yet in Ballerina bindings. So what we can do is we can create a Ballerina object and get this value into a Ballerina object, or we can cast this into a map. I will start by explaining. I will first show you how it can be taken into a Ballerina object. So let's say map object. We support to and we can print this out. So I have given this file path, but I've not added a file here, a YAML file here. So just to see, let's build this and see if the error path is executed as expected. Okay, so I'm gonna build the project. Sorry, I give the project. I should give the module. Okay, so it got executed successfully. Now I will run the module. So could not load the file because it's not found. So I will just create a new YAML file with the name. And I have a YAML file here in this project. So just copy the same thing. Okay. Again, to the footer. Now we run the module again. Okay, so it's loaded as expected. And now let's look at, also I want to point out something. If you see, we are creating a file input stream and it's added into an input stream. So subtyping is supported in Ballerina, so in Ballerina bindings. And now we will look at how Java casting can be done. Okay, how Ballerina bindings provide support for Java casting. Okay, so now I'm gonna create a map object here, and then I'm gonna cast this output into a map object. Okay, so I'm going to cast this into And then, so basically the normal casting that is there in Ballerina does not work with the Java Ballerina binding objects. So we have provided a cast method inside the Java module in order to do this. So how you can use it is you should give the object and then type disk of the type that you want to map into. And so I have to import the Ballerina module. Okay, and here it is not showing itself, but since this could provide a Java class cast exception. Okay, so this is either a J object or an error. So I'm adding a check here in order to handle this, and I will return and this. Actually, on second, we can keep the method as it is. So that, if not, you will have to handle it there again. Okay, so now we have an object, and let's see something that we can do with this. Let's see this. Can get a value, or I can get the values this here, or the entry sets. Get the entry sets first and print it. Okay. Yeah. Or you can print the values. Or you can create, or you can do, yeah, let's check the output of this. Okay. Okay. We can do something like getting the value of the invoice element. So this get method expects an object. So in this scenario, we can't pass a string straight away. I know I said strings will be mapped on to Java strings will be mapped on to Ballerina string type. But the thing is here, it will be expecting an object, not a string specifically. So we will have to create a string object and then pass it on. Okay. Creating a new string. And, okay. Let's see what of this. Okay, as you can see, the value of this invoice element will be printed. So I think you get a basic idea about how Ballerina bindings could be used in a scenario where you need to use Java libraries. So I think this pretty much covers the demonstration. Let's look at the slides again. So yeah, so let's look at how Java libraries could be packaged with Ballerina programs. So basically, probably most of you already know. So the ballerina.toml file is the manifest for a ballerina program, where you get details about the ballerina program, dependency modules used, and platform libraries used, etc. So if you are going to package a Java library with the Ballerina program, or if you're going to call a Java API from the Ballerina program using a Ballerina bindings, you will have to specify the platform libraries that are required. So if it's a jar file, or if it's a class path that you want to specify, you can specify it using the path field. And if it's a Maven dependency, you can specify it like this using the group ID, artifact ID, and the version. And if you specify a Maven dependency, then like I showed you before, the Maven dependency and its transitive dependencies will be resolved by the tool, and the same happens during the build commands and the run commands as well. So those will be resolved into a directory called platform libs inside the target directory. So if we look at the example, okay, yeah, so as you can see, in the current example, this is the Maven dependency that was added. So we didn't add it explicitly. When you run the Bindgen command, it updates the Ballerina toml file with the details of platform libraries that are used. But this is applied only with the Maven option, not with the class path option. So if we specify a Maven dependency, it will add the dependency and its transitive dependencies here. So, I would like to show you another scenario where the toml file is updated with the transitive dependencies. So this is a scenario where we're creating a PDF using the iText PDF jar. And here the dependency is added along with the transitive dependencies. So you don't have to worry about it. And also if you check the target for the platform libs directory along with the jars. Same in this scenario as well. So I think that's about it from the. Okay, so I think that's about it for the demo and the presentation. So I have used some references. The main reference that I'm using is the Java, calling Java code from Ballerina, the Learn Guide that is there in our website, ballerina.io. So that has a complete guide on Java interoperability, the Bindgen tool, and foreign function invocations and all that. And then you can also refer Ballerina by examples. So there are a few examples related to objects, and I'm using the invoking Java methods example, and also the Ballerina, API docs of the Ballerina Java module and the Java 8 API, doc API. And also the documentation on SneakyML. So I think now we can move on to the open discussion. And so apparently there's a question on YouTube asking what Java version do you use for the current Ballerina? So this is Java 8. So basically the 1.2.x branch is on Java 8. But if you're using Swan Lake, then you can use Java 11 for this. Yeah, so basically the Swan Lake latest preview is on Java 11. Yeah, so if there are questions or questions about the session today, or about Ballerina in general, you can ask and we can discuss it with the Ballerina team and the community. Yeah, again, so this session will be recorded and we'll be uploading it in YouTube, so you can refer it later if you want. Yeah. So if you have any questions, you can ask. So I'll give a few minutes. If anyone wants to ask a question, we can. So while you all think of questions to ask, so if you want to get more involved with Ballerina, you can use our Slack channel, where, okay, so there's a question. Okay, so there's a question asking whether the code I used in this presentation is available in GitHub. So I was getting into that. We will be uploading the presentation and the resources to our GitHub repository, Ballerinalang. Yeah. Yeah, so as I was saying, you can join our Slack channel if you're interested in finding more about Ballerina, and you can ask questions there. You can have discussions there, and also we have a Google group where you can join. So you can get the links to those from ballerina.io/community webpage. Yeah. Okay, so there is no question. So Anjan is asking whether we can get the original method name, param names, rather than param 0, param 1. Not sure the scenario that you're referring to, if it's the external methods. Sorry, he means this R0, param 0, that. No, we don't. Sadly, we don't. The thing is, this is made on top of Java reflection. So what you can get is the type and the number of arguments for a particular method. So this is the current implementation, and maybe we might, I don't know, but maybe we might be able to improve this in the future. But as of now, these will be the arguments. So, but even though this is there, you can still get the type of the argument. So I guess it should be enough to get on with the work. But to answer your question, no, we can't get the original of the method parameters and arguments. Okay, so like I said at the beginning of the session, you can subscribe to the Notify Me form and get, if you're interested in getting notifications on upcoming Ballerina community calls. And also you can use the suggestions form to provide suggestions, suggest topics for future community calls as well. So if there are no more questions for the day, we can wind up the session. Yeah, so thank you very much for joining in, and we hope to see you in the upcoming community calls as well. Yeah, so we can wind up the session. Thank you.